Today we will be looking at Unit 3, Day 4, which is regular polygons. So before we start today's examples, there's a few things we need to recall. Firstly, the sum of all interior angles in a polygon is given by the following equation: 180 times n, which is the number of sides, minus 2. We also found from last day's lesson that the sum of all the exterior angles in a polygon is always going to be 360, no matter how many sides the polygon has. Today we'll be looking at the term regular polygon, and this is just referring to a polygon where all sides are equal. So for example, a regular triangle is what we would call an equilateral triangle because all sides in an equilateral triangle are equal. Also, a regular quadrilateral is just a square because again, all sides on a square are equal. Two important properties that go hand in hand with a regular polygon are the following. So since all sides are equal in a regular polygon, the following two properties exist as well. So first of all the interior angles will always be equal in a regular polygon. Secondly, all exterior angles will always be equal in a regular polygon. So knowing this, let us now work on a few examples applying this knowledge. So example 1, consider the following exterior angles. Determine the number of sides of each regular polygon. So for our first example, we're given 60 degrees as the exterior angle of such a polygon. And since we know that the sum of all exterior angles is always 360, we can simply divide 360 by 60 degrees to see how many sides it has. So the number of sides of this polygon will be equal to 360 degrees divided by 60 degrees, again because we know that all exterior angles are equal in a regular polygon. And we divide this out, we figure out that n is 6, therefore this shape is a regular hexagon. Now for the second example, we can do the same thing. The exterior angle we are given is 3 degrees, and we know that all exterior angles are equal in a regular polygon. So to find out what this polygon is or how many sides it has, we divide 360 degrees by 3 degrees, and we get n is 120, meaning that this regular polygon has 120 sides. So we call it 120gon. In our third example, it says, in a regular polygon, the size ratio of an interior angle to its adjacent exterior angle is 5:1. Determine the number of sides of the regular polygon. So first, let us draw out what they mean in the question. So they tell us that the interior angle is 5 times bigger than the exterior angle. So as you can see here, the interior angle is 5 times as big as the exterior angle. So next thing we need to do is solve for x. So from this equation and the diagram, hopefully you can see that we could use our supplementary angle theorem because we know that these two angles would total 180 degrees. So 5x plus x equals 180 by our supplementary angle theorem. Now we simplify this, so 6x equals 180. Now we can divide both sides by 6. Cancels out to x equals 30 degrees. So now we know that our exterior angle of this regular polygon is actually 30 degrees. So now to find the number of sides, we do what we did in the questions before. The number of sides is going to equal 360 degrees divided by 30 degrees. So our n equals 12. Therefore, this is a regular dodecagon or a 12gon.